Welcome to the Deep Dive. This is where we take that pile of sources. You send us articles, research papers, you name it, and we really boil it down. We want to find those surprising nuggets of knowledge, give you that shortcut to feeling genuinely up to speed. And today, we're diving into something that's, well, it's not just evolving, it's actively changing things right now. Agentic AI. Now, you've probably heard plenty about AI, right? Maybe the older rule-based stuff or the generative models everyone's been playing with lately. But the big question we're tackling is, what exactly is this agentic AI, and how is it really fundamentally different from what you might already know? Because, and this is the key bit, we're moving beyond AI that just responds. We're talking about AI that can actually act.
That's it, exactly. That's the core shift. Agentic AI isn't just, another small step. It's a major leap. It fundamentally changes how AI can operate. Think moving from a digital assistant to, well, a true digital agent. These systems are built to learn, yeah, but also to make complex decisions and actually interact on their own within complex environments. It's a really profound jump forward in how AI is going to deliver solutions, especially, I think, for businesses.
Okay, let's unpack that a bit. When we say agentic for AI,
Yeah.
what does that really mean? You're saying it's about independence.
Yes, a remarkable degree of independence. It can start tasks, finish tasks, make sophisticated choices, and take actions autonomously.
So it's not just doing what you tell it. It's more like it has its own sense of purpose.
Yeah.
To follow goals, learn, adapt. That sounds like a huge jump.
It absolutely is. And maybe the best way to grasp it is to compare it to what came before. Think about traditional AI. Useful, sure, but mostly rule-based.
Like if this, then that. Very predictable.
Exactly. Great for simple automation, like a factory robot doing one thing over and over. But it's stuck within those rules. It can't really adapt or learn beyond its programming. It needs those rules. It needs human intervention. Effective, but rigid.
Okay. And then came generative AI, the LLMs.
Right. A massive leap. Suddenly, machines could generate really human-like text, code, images, amazing stuff. But, and this is critical, they're mostly sophisticated tools. They respond brilliantly to your prompts.
Yeah, you have to ask them the right thing.
Precisely. They don't proactively start doing things on their own. They need that user guidance, like an artist waiting for a commission, as you said.
Got it. So agentic AI, that's
Yeah.
the third wave.
You could think of it that way. Its main thing is goal-oriented action and decision-making. It runs with high autonomy, minimal human checking in needed, and it learns through reinforcement learning. It gets better from its own experiences, interacting with its environment, like learning to ride a bike. You don't program every tiny muscle movement, right? You try, you wobble, you adjust based on feedback. That's kind of what these agents do in digital spaces.
So for a business, this isn't just tweaking things. This sounds like a potential game changer. You're saying it can deliver end-to-end solutions, perform complex tasks autonomously to reach business goals. That's quite different.
It really is. It moves beyond just reactive responses to proactive self-directed action. It changes the possibilities, letting businesses potentially offload entire workflows, not just small tasks.
Wow. Okay. So what gives them this power? What are the core characteristics?
Well, several key things enable this. First, obviously, autonomy. The power to start and finish tasks without constant oversight. They're not waiting for you to click next. Then, reasoning. This is about sophisticated decision-making, weighing context, trade-offs. It's not just following a script. It's evaluating paths like a consultant weighing business options.
Right. Thinking it through.
Exactly. And reinforced learning, which we mentioned, that continuous improvement through interaction and feedback, essential. Plus, strong language understanding using NLP and NLU so they can grasp complex, nuanced instructions, not just keywords. And finally, workflow optimization. This isn't just about being fast, it's about intelligently executing multi-step processes, maybe even across different departments, efficiently.
That's a powerful mix. Now, something to clarify. You hear agentic AI and AI agents. Are they the same thing?
Good question. No, not quite. Agentic AI is the big concept, the paradigm systems acting independently towards goals. AI agents are the actual components within that system. They're the individual workers, each often specialized, that execute the tasks. Think of agentic AI as the whole orchestra, maybe, and the AI agents are the individual musicians, each playing their part.
Okay, that makes sense. The concept and the workers. So what kinds of workers are there? What do these agents do?
There are several types. You have agent assist, which is more about human-AI collaboration on daily tasks, like helping a support agent find info faster.
Right, augmenting the human.
Exactly. Then generative information retrieval agents. They're great at pulling together info from lots of diverse, maybe messy sources. Think like a super researcher. Contrasting that, you have prescriptive knowledge agents. These are designed for highly regulated areas, ensuring everything stays within strict compliance rules, like a tireless compliance officer.
Okay, crucial for finance or healthcare, I imagine.
Definitely. And for real automation, there are dynamic workflow agents, sometimes called action agents. These are the conductors. They can generate and run complex workflows across different apps, figure out the right APIs, the best sequence, all to fulfill a user request, like processing a new customer setup from start to finish. And lastly, user assistant agents, helping individual users directly with their daily tasks, like a very capable personal digital assistant that can do things, not just find info.
You mentioned orchestration.
Yeah.
How does that fit in, making them all play nicely together?
Precisely. Agentic orchestration is about grouping these diverse agents into logical domains, maybe IT, HR, engineering. This simplifies things for different teams. They can use these tools without getting lost in the weeds of managing every single agent. It ensures everyone aligns with the overall AI strategy, even if they're working somewhat independently. It fosters this ecosystem where agents work together smoothly for better coordinated results, like that well-rehearsed digital orchestra.
Okay, this is where it gets really interesting for me. Let's look under the hood. The architecture. How do these systems actually work? What are they built on?
Right, the foundations. A few key principles here. First, modularity. Breaking things down into specialized modules. Think Lego bricks. Each brick does one thing well. You can swap them, upgrade them, without rebuilding the whole thing. Makes development, maintenance much easier.
I like that Lego analogy. Makes sense.
Then scalability. These agents need to handle growing demands, so they use distributed computing, cloud infrastructure to scale up resources as needed without slowing down. Interoperability is key to making sure all these different modules and systems can talk to each other smoothly using standard protocols. And underpinning it all is reinforcement learning, RL. That's the engine for continuous improvement, learning from every interaction, every bit of feedback.
And how does this modularity play out in practice? Are there different setups?
Generally, yes, we see two main architectures: single-agent systems and multi-agent systems, or MAS. A single-agent system is just that one AI agent, maybe with a set of tools tackling specific problems. The advantage is simplicity. Easier to design, manage, consistent decisions because there's no coordination needed. Good for focused tasks.
But limited, I guess.
Exactly. They tend to be narrowly focused, hard to handle really diverse tasks. Scaling them up often means a major redesign, and they can hit limits on memory or processing since one agent does everything, like asking one expert to run a whole department.
Right, so the alternative is multi-agent systems.
Yes, MAS. This involves multiple independent agents, often each powered by its own language model, collaborating on complex tasks. They leverage different roles, personas, tools bringing specialization. The big win is scalability. You add agents as needed without a huge redesign. They also have built-in fault tolerance. If one agent struggles or fails, others can potentially step in. So you get specialization, collaboration, resilience. It's a very powerful, flexible setup for complex, evolving challenges, like assembling a digital super team.
Okay, assembling the team. So let's walk through it. I give it a task.
Yeah.
What happens next? Step by step.
It usually unfolds in about 4 stages. First, you provide the instruction, just a natural language prompt telling it what you need.
Just talk to it.
Pretty much. Second, the agent system plans, allocates, and executes. It takes your prompt, turns it into a structured plan, breaks it into tasks, and assigns those tasks to the right specialized subagents. They coordinate using the available tools and data.
Okay, it figures out the how.
Right. Third, it iteratively refines the output. It might ask you for more details, check its understanding, refine things based on your feedback until it's confident it has the right result.
So there's a bit of back and forth sometimes.
Can be, yes. And finally, fourth, the agent executes the action to actually complete the request. It closes the loop from understanding to doing.
And inside each individual agent, what makes it tick? What are its components?
Good question. Each agent typically has 3 core parts. First, the prompt. This is its blueprint, its guide. It defines the goal, the constraints, how it should operate.
The mission brief.
Kind of, yeah. Second, memory. This is its knowledge base, its history of experiences. It uses this for context, learning from past interactions. Could be conversation history, extracted facts, its working knowledge.
Like our own memory.
Exactly. And third, tools. These are the instruments it uses to interact and act APIs, functions it can run, services it can access. Its digital toolbox for getting things done, like sending an email or querying a database.
Okay, prompt, memory, tools. Got it. So bringing this back to the real world, What does this mean for you, the listener? We've seen things like the Rabbit R1.
Yeah, those consumer devices offer a glimpse, acting like a universal remote for your apps through AI.
But for businesses, the potential seems huge. You mentioned a fully autonomous digital workforce. That sounds transformative.
It is, potentially. It shifts AI from just being a tool for productivity boosts to something that can genuinely understand and execute complex business goals from end to end, often needing less direct human input.
And where are we actually seeing this applied now?
It's starting to make inroads in several areas. Supply chain management, for one. Analyzing real-time disruption data, predicting demand better, streamlining complex workflows. It's moving beyond just historical analysis.
Reacting faster, anticipating problems.
Precisely. And in improving code and quality management, it's changing software development. You've got text-to-code agents generating boilerplate code, ensuring standards are met. Imagine automated code reviews catching issues way faster than humans can. Automating incident response, triggering alerts, notifying teams, even drafting reports. And speeding up testing cycles with automated test execution, analysis, even updating bug trackers. It frees up engineers for more complex problem solving.
Okay, that's significant for tech teams. What about customer service, beyond just better chatbots?
Oh, definitely beyond chatbots. Agentic AI enables things like anticipatory service. The AI monitors systems or customer behavior to prevent problems. Imagine it notifying a customer about a shipping delay and offering solutions before they even ask, or suggesting alternatives for something out of stock. Proactive help.
Like my car warning me about low tire pressure before I get a flat.
Exactly, that kind of proactive intervention. It can also handle complex inquiry resolution. Think multi-step problems, verifying a billing error, issuing the refund, updating the customer record, all handled seamlessly by integrating with back-end systems, and it powers much deeper personalized engagement. Analyzing customer data continuously to deliver truly tailored content, recommendations, offers across every touch point, dynamically adjusting suggestions on a website based on what you're doing right now.
And you mentioned OnTrack, a real-world case.
Yes, OnTrack, a large regional carrier, faced a huge spike in customer queries. They implemented AI agents using specialized models. The result? A big drop in the need for live agents because way more queries could be handled through self-service automatically. It wasn't just cost savings. It improved their processes, the customer experience, and used their resources more effectively. It shows this isn't just theory.
It really drives home the impact. But, okay, it sounds powerful, but you said it's not one size fits all. Implementing this must be tricky.
It definitely requires a strategic approach. It's not plug and play. You absolutely need clearly defined objectives. What specific business outcome are you aiming for? Vague goals won't work. You need to map out the organizational touch points, which departments, processes, data sources will be involved or affected. And, critically, you need to foster a culture of continuous learning. This tech evolves fast, and your teams need to adapt with it.
So what are the big hurdles, the challenges businesses face when trying to bring this in?
There are several significant ones. Explainability is a big one. It can be hard to understand why an agent made a certain decision. That black box problem makes troubleshooting and trust difficult.
Right, if you don't know how it works.
Exactly. Then bias. If the training data is biased, the AI can perpetuate that, leading to unfair or inaccurate results. A major operational and ethical risk. Data privacy and security are huge, obviously. These systems often need access to a lot of sensitive data, and they act autonomously, which links to accountability and governance. If an autonomous agent messes up, who's responsible? How do you ensure oversight? Integration complexity is often underestimated. Meshing this with existing, often older, systems can be tough. And finally, you need robust risk management to anticipate and mitigate potential failures, weird behaviors, or damage to your reputation.
Okay, quite a list. So how do companies navigate that successfully? What are the strategies?
Gradual deployment is smart. Start with pilot projects in controlled environments. Learn and refine before going broad. Using specialized models for specific tasks usually yields better accuracy than trying to use one giant general model for everything. Continuous monitoring is non-negotiable. You need visibility into what the agents are doing for transparency and accountability. Layered security is crucial, multiple defenses to protect data and control agent actions. And collaborating with AI and cybersecurity experts is often essential to get the integration right. But maybe the most important thing is mindset. Remembering the goal is to enhance human capabilities, not just replace them. They're powerful partners.
Partners, not replacements. Got
Yeah.
it. So looking ahead, 2025 and beyond, what trends are emerging?
Well, the need for high-quality, diverse training data is only going to intensify. That's becoming absolutely critical. And this is where synthetic data is becoming really interesting. It helps overcome challenges with regulations, data sensitivity, or just not having enough real-world data for rare events. You can create realistic, varied data sets without using actual personal information. Huge potential there for training robust agents, especially in areas like finance or healthcare.
So creating fake data that's good enough to train real AI.
Essentially, yes, highly realistic, but artificial. We also expect domain-specific intelligence to become more important agents that deeply understand specific industries, not just general knowledge. And multi-agent orchestration will get more sophisticated, allowing agents to collaborate on much more complex, cross-departmental workflows, really integrated operations. Probably the most compelling approach, though, is combining synthetic and real-world data. Using synthetic data to fill gaps, simulate rare scenarios, reduce bias while still grounding it in real data. Gives you the best of both worlds, boosting model robustness, assuming you keep a close eye on data quality.
So it sounds like agentic AI really is poised to, well, revolutionize how businesses work. Giving AI that independence, that problem-solving ability,
Yeah.
it opens the door for truly seamless collaboration between AI and people.
It does. Tackling complexity, making better decisions. It's about intelligence-driven autonomy, moving beyond simple automation.
But it hinges on getting that balance right, doesn't it?
Absolutely. Realizing the potential demands that delicate balance. Transparency, accountability, human oversight. They aren't optional extras. They're fundamental to making this work ethically and effectively. Without that foundation of trust and control, the whole thing risks falling apart. It has to be a partnership.
So thinking about all this, what does it mean for you listening? As this agentic AI becomes more common, weaving into the technology you use every day, what new questions might you start asking about the autonomy of the tools and devices you rely on? Something to think about. We encourage you to keep exploring because this deep dive, well, it's really just scratching the surface.